Alright, today we are looking at finding rates of change and slopes. And we are also looking at how a rate of change relates to a slope of a line. So first let's just look at some vocab. A rise, when we're talking mathematically, is a change in the x values of a function. The run is the change in y values. Then the slope is the ratio of the rise and the run for any 2 points. And we can, a lot of times you'll see this written as an equation where slope is equal to the rise over the run. Now probably the hardest part about working with slope is that it's different from when you were graphing normally. Typically you're always thinking x than y, when here we're actually thinking more of a y than x type of thing. And the biggest thing to remember too is that rate of change, whenever you see that, is really just the same thing as finding the slope of a line. So now what does this actually mean when we're looking at a line? So when we are looking at a line, there's lots of points along the line. So in this case, you'll see a point here and a point here. Now any point along this line would give us the same slope. So remember, slope is always rise over run. So we're always looking at how are we changing vertically compared to how are we changing horizontally. Well, one way we can do that is actually counting our different numbers out. So here, if I was going to count of how I got from this point to this point, one way I could look at it is that I go 1, 2, 3. So I went down 3, and then I went 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right, so that would be a positive 9. So we would have negative 3 over positive 9, which if we divide each by 3 would equal a negative 1/3. Now, if you'd started with the other point, we'd still do the same thing, 1, 2, 3, but now it's a positive 3, but now 2, 3, 4, 5, 6, 7, 8, 9, going negative 9. So I have positive 3 over negative 9 would still divide the top and the bottom by 3, and I would still end up with a quantity of negative 1/3. So remember, we're always looking at rise over the run, and it really doesn't matter which way we go as long as you are consistent. Alright, so now I'm going to go ahead and pause the video, and I want you to try this one on your own. See if you can figure out the slope for this line. Now if you look, we kind of already have 2 points picked out, but really, like I said, you can pick any points. I always suggest using points that, like these, are crossing right at the intersection of our grid lines. So like here, we wouldn't want to use that point because it'd be hard to estimate, but we could use this point right here. We're going to go ahead and count. So I try to always go left to right. So my rise, if I go here, is down 1, 2, so I go down 2, and I'm going over 1, 2, 3, 4, 5, positive 5, so our slope is negative 2/5. Now let's look at a couple different types of lines. Here you notice we have a vertical and a horizontal line. On this one, our rise is 1, 2, 3, 4, 5, 6 between our points, but we're not moving left or right, so our run is 0. Because of that 0 in the bottom in our denominator, this is what's called an undefined slope. Since we can't divide by 0, that makes this one undefined. Now on the one to the right, my rise is 0 because I'm not moving up or down, and then my run is 1, 2, 3, 4, 5, 6, 7, or maybe just 6. Yeah, it's just 6. But really it doesn't matter because any number divided by, or 0 divided by any number is just 0. So this one would be a 0 slope. So it is important to realize the difference. Now some people use the term no slope. I tend to be careful using that just because sometimes people confuse it between undefined and a slope of 0. But the biggest thing is to remember that 0 on the bottom, it's undefined. So as shown in the previous examples, slope can be positive, negative, 0, or undefined. You can tell which it is of these by looking at the graph of a line, and we actually don't even need to calculate the slope. We can tell if it's positive, negative, 0, or undefined just by looking at it. Remember, we're always reading left to right. So here, my line is rising from left to right, so this would be a positive slope. Here, my line is falling or going down, so it's a negative slope. This one is our 0 slope, it's a horizontal, and then our undefined is that vertical line. Okay, it's quiz time for you. Go ahead and pause the video, see if you can tell if these are positive, negative, 0, or undefined slope. On this first one, if you look, we're going uphill as we move left to right, so this would be positive. And the next one, even though it's very, very little, it's still a negative slope because it's going downhill as it moves left to right. We can also actually compare slopes by comparing the ratio between the two. So in our first example here, we see we have a slope. The red line is a slope of positive 1/2, and our blue one is a slope of positive 4. Well, the line of 4 is steeper than the line of a slope 1/2. So the bigger the number, the steeper the slope. So here, negative 2 is steeper than negative 1. Now this one's confusing because I know negative 2 is bigger than negative 1, but notice we use those absolute value symbols. And what's happening there is because the line is rising or falling at a bigger number, that's why it's a steeper line. So same thing here. Negative 3, even though it's a negative, has nothing to do with the absolute value. It would be 3, and the absolute value of 3 is greater than the absolute value of 3/4. Now here's something that is very important for you to get down in your notes and to become very familiar with because it's going to come up a lot. And that is our slope formula. We can always find the slope of a line by finding the difference in the y values and setting up as a ratio to the difference in the x values between any 2 points on a line. Now typically we're going to name the points x1, y1, x2, y2. It really doesn't matter which point is which as long as you are consistent. And our formula is always going to look like this. M is a really common thing that we use to stand for slope, is equal to y2 minus y1 over x2 minus x1. And now here's an example where they use 2 and negative 3, 1 and 4. So they've chosen to use 1 and 4 as their x2, y2 points. So 4 minus negative 3, 1 minus 2. Like I said, notice the same thing as they're consistent. And I can show you that by taking negative 3 minus 4 and then 2 minus 1, and I'll find the same slope. Negative 3 minus 4 is negative 7. 2 minus 1 is 1. Negative 7 divided by 1 is negative 7, which is the same slope they had there. Alright, so now I want you to pause the video and try to find the slope that goes through these 2 points on your own. So like I said, it doesn't matter which point you choose to go first. I typically always just write them in the order that they're given just because I find that to be easier and you don't have to remember. So if you do that, we do our y points first, which would be 5 minus 1, over the difference in our x points, which is going to be 2 minus 8. 5 minus 1 is 4. 2 minus 8 is negative 6. Each of these are divisible by 2. And this becomes 2 over negative 3, which is the same as negative 2/3. That negative sign doesn't matter where it goes. We can do the same thing with points given on a graph. instead of counting. So if they give us the 2 points, I'm going to do -2 minus 2 over -2 minus 0, y over x. -2 minus 2 is -4, -2 minus 0 is -2. So our slope is actually a +2. And we can check that. If I go up here and check my rise, 1, 2, 3, 4, I went up 4, and then my run was 1, 2, which still gives me a slope of 2. There are also times where they might ask you to go ahead and find the slope from points on the table. Once again, we can choose any 2 points. So just for sake of ease, I'm going to use my 0s and 1s because they're easier to work with. So first I'm going to do my difference in my y's. So I'm going to do 1 minus -1. So remember, I'm using the points 0, 1 and 1, -1. And since I use my 1 point first, I have my 0 first for x, 0 minus 1. Now I'm going to double slash. So 1 plus 1 is 2, 0 minus 1 is -1, which gives us a slope of -2. Now here we're going to use the slope formula, the slope to find the slope of a line. We're going to use our points. So I'm going to have 12. Now in this case, I might actually use my second point first just because I'm subtracting bigger from smaller, or smaller from bigger. So I'm going to do 24 minus 12, and then I'm going to do 4 minus 2. Like I said, I just kept it consistent. 24 minus 12 is 12, 4 minus 2 is 2, so our slope is 6. And what does the slope represent? It represents the cost of electricity per month. One last way, because sometimes we're given equations in standard form and we're not given a table or a graph and they want us to find the slope. So first thing we can do is actually find the x and the y-intercept. So if you remember, that means at one point I'm going to put 0 in for y for my x-intercept and 0 in for x. So this one would be 4x minus 2 times 0 equals 16. 4x equals 16. Divide by 4. X will equal 4. So my ordered pair would be 4, 0. Now same thing, 4 times 0 minus 2y equals 16, negative 2y equals 16, divide by -2, y is equal to -8, so my other point would be 0, -8. And now that I have my x and y intercepts, I can use my formula. So I have 0 minus -8, double slash there, and then I have 4 minus 0. 0 plus 8 is 8, 4 minus 0 is 4, giving us a slope of 2. If you have any questions, let me know. Otherwise, go ahead and get started on your homework.